What's up guys, my name is Ryan45678 and today I'm bringing you a Minecraft video on how to make a simple combination lock. Now this is a design I came up with myself based on a few simple logic circuits, so if you want to learn how to do those I'll put a link down below. But anyway, let me show you how this works. You press a button to put in the combination, and as long as you have the wrong combination the thing is not going to open the piston door. It's only until you get the right combination then you can go through the door. So as I said before, the redstone behind it is a couple simple logic circuits that are pretty compact and made to fit in a 1 block wide space. So even if you don't know anything about logic circuits or redstone, you should just be able to follow the video and you can build this thing yourself. So let's get started and build it. Alright, so this design is pretty modular. You can basically have as many inputs as you want for your combination. I'm going to stick with 6 for this video. But basically, that's your input, and this right here will show you whether your input is on or off, so that way you're not guessing. And then what you need to do is put a repeater right here next to your input, a sticky piston with a block, another block, another repeater, another block again, and then a piston on top of that. This right here will act as a monostable circuit, and if you don't know what that is, it's basically a circuit that will give a 1-tick pulse to this repeater, which will in turn cause this sticky piston to spit out its block, like so. Right, and then it will take it back. And this is what will create our T flip-flop, which is the first part of the circuit that will allow us to use the button as a toggle rather than a pulse. So instead of a block here, you actually need a cauldron, and it's something to do with the properties of water in a cauldron that will give a comparator a positive input. So after this, you need to place a comparator here, and that should be our completed T flip-flop that takes input at the end, like that. So basically, you just repeat this for each number of inputs that you want to have. So I'll build this really quick, and I'll probably speed through it. I may not, but this is just so you can get an idea of how to build one of these, and then you can go ahead and build all 6 of them, or however many you want. Alright, so at this point you should have all 6 of your T flip-flops built, and I know this is not the most compact design for a T flip-flop. There's the piston design, but you can't do that in a 1 block wide space. There's also the dropper design, which I believe fits in a 2x2, which would be more compact than this, but I think it's a lot better to build something that's simple, if you can, than something that's super compact, because you can still fit this with your buttons being side by side, and it's a lot easier to build, in my opinion. So to make sure your T flip-flops are working, you can go ahead and press each one of these buttons, and you should be getting a comparator output for each one of those, and that looks good. So we'll go ahead and press them again, and you should now have no input for each of these, and that looks good. So that's good. Now on to the next step, which is wiring the lighting output so you're not confused on whether your button has been pressed or not. So what we do here is basically copy the design on this side to over here, but instead of going out, you put it going back towards the lights. So put comparators here, and then what we need to do is put a block here and line them this way, and then put torches to carry the signal, so that way the lights will be individually powered. And now one thing that I ran into was mainly like a logical concept of whether the light was on or off. So it bothered me that the lights were on, but this was like what I assumed it was off. Like this is an off signal, but in reality it doesn't really matter, because you're going to be setting the combination inside the circuit. So what you're going to be seeing as on doesn't really have to be actually on or off. It's just what you perceive as on or off. So go ahead and turn these and make these all be off. And so we'll use this as our off state. Okay, now it looks like we're ready to set our combination. So what I'll do is I'll go ahead and put in the combination that we want, and then I'll explain how to go about setting the combination while I set it up. So basically what you want to have is the combination that opens the door needs to be the only combination with all the outputs being off. So in a logical sense, that means it's basically a giant OR gate. If you don't know what that means, you can look it up, and there's other videos that can explain it better. But basically in an OR gate, you have inputs, and if any of the input is on or 1, true, one of those, then the whole output will be true, no matter what any of the other inputs are. So what you want to have is a false output, or off, to be the one that opens the door, because if any part of the combination is wrong, it will transmit an on signal, and it will skew everything else and cause the whole output to be on, which will close the piston door. So in order to do that, we need to fix these. These are currently on. We want them to be off in the final output, so the door will open when it's set to these positions. So we'll use an inverter like that, and then I actually need one more row of material. And for these, they're already off, so we just transmit them as they are using repeaters like that. Make sure they line up with the torches, because we're going to be using redstone right here to link them together, and then bring them back over here to where the piston door is going to be. So one other thing to be aware of, especially if you have a lot of inputs, you want to make sure that your redstone will reach, because I ran into an issue when I first built this thing that the piston door would open with multiple combinations, and it was because these signals reached, but I didn't have my repeater close enough, and one of these signals wasn't actually being transmitted because it was too far away, while these were actually close enough. So make sure you have your repeaters close enough to where your signal will reach. Otherwise, your door will open when you don't want it to be open. So I'll go ahead and set this up really quick, and I'll be right back. Alright, so that's the piston door complete, and since we have it set on the combination right now, the door is open. If you don't know how to do a basic piston door, this is one way to do it. You put 2 sticky pistons there, the block's there. Make sure you have the redstone going into the top piston on that block, because that will power both. And that should be it. And you want to make sure your default state is on, so you might need an inverter for what you're doing. But let's go ahead and test this thing out, just like the other one over there. As you can see, it's reset everything, so the door is now closed. And again, as long as we're putting in an incorrect combination, the door is going to remain shut, and we're not going to be able to get in until you put in the right combination, which is that. So there we go. That is a simple but complicated redstone combination piston door. Let me know what you thought about this build in the comments below. Don't forget to leave a like if you liked the video, and subscribe if you want to see more, and I will see you guys later. Bye.